Welcome to day 2 of sequences. I'd like you to take a moment, pause this video, and try the warm-up, each of these problems in the warm-up, and then play to check your answers after you're finished. All right, take a moment to check your answers for each one of these. So in number 1, I first had to figure out what type of sequence this was. I noticed the pattern. I think it was kind of pretty obvious that we were adding 3, but remember, if it's not obvious, you can always check by taking the second term and subtracting the term in front of it. So -9 minus -12 does give me 3. Doing that again with the third and the second term, -6 minus -9, and I'm getting the exact same value of 3. So I know that that is a common difference and that this sequence is arithmetic. So the common difference is 3. So if I know the common difference, then I also know the formula for an arithmetic explicit, which is a sub n equals a sub 1 plus d times the quantity of n minus 1. So substituting in the d value we just figured out of 3, and the first term, a sub 1, is -12. So substituting that in, and again, you can either stop there or we generally prefer that you keep going and simplify that. So a sub n is equal to 3n minus 15 after distributing the 3 and combining like terms. That is the arithmetic explicit formula. So I'm going to use that then in part B to find the 12th term by substituting 12 in for n. So a sub 12 is equal to 3 times 12 minus 15. 3 times 12 is 36. 36 minus 15 is 21. So the 12th term of this arithmetic sequence is 21. Number 2, identify the sequence as arithmetic, geometric, or neither. Well, hopefully you discovered that it's neither. It's not arithmetic or geometric. Why? Because again, if we subtract the terms 1 minus 1, we get 0, and 2 minus 1, we get 1. They're not the same value, so it's not a common difference. It's not arithmetic. Checking to see if it's geometric. 1 divided by 1 is 1, and 2 divided by 1 is 2. Again, not the same number, so it's not geometric, and that's not a common ratio. So if it's not arithmetic or geometric, that means it has to be neither. Now, that doesn't mean there's not a pattern. There is. However, the pattern is just not that we're constantly adding or multiplying. So what is the pattern? Well, hopefully you looked at it and discovered the pattern. The pattern, this actually is a famous sequence called Fibonacci sequence. And the pattern with Fibonacci sequence is that we take the first term and add it to the next term, 1 plus 1, and we do get the third term, which is 2. Continuing to do that. So the term in front of the second term and then the third term, the term in front of it, 1 plus 2 is 3. That's how we get that fourth term. To get the fifth term, 2 plus 3 is 5. To get the sixth term, which is what we're looking for, 3 plus 5 is 8. To get the seventh term, 5 plus 8 is 13. And to get the eighth term, a sub n, I did 8 plus 13 and got 21. So my Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13, 21. And again, we could keep going with that forever using that pattern. Okay, hopefully you were successful in the warm-up. So today's lesson, we are going to continue on with what we did yesterday, diving a little bit deeper with arithmetic sequences. And so let's take a look at this example, copy this into your notes. So we're going to find the 7th term of the sequence with the 50th term being 488 and the common difference being 10. So notice if I want to try and use my explicit formula, my explicit arithmetic formula, I would start off writing a sub 7, because that's what I want, right, is the first term, a sub 1 plus 10 times 7 minus 1. So I have the 7th term is equal to the first term plus 10 times 6. So I have the 7th term is equal to the first term plus 60. But the issue there is I don't know what the first term is. So I'm kind of stuck for a moment. But don't get too panicked because we know the 50th term. So let's go ahead and use the explicit formula and what we know about the 50th term. So in other words, the 50th term is equal to the first term plus the common difference, which is 10, times 50 minus 1. Again, just substituting into that explicit arithmetic formula. So that means the 50th term is the first term plus 10 times 49. And don't panic, we don't know the first term, but we do know the 50th term. So I'm going to go ahead and substitute that 488 in. And 49 times 10 is 490. And subtracting 490 from each side is going to get me that a sub 1 value. So 488 minus 490 is negative 2. The first term is negative 2. That's good news for me because that's what I needed to figure out the 7th term. So let's go back over here now. The 7th term is negative 2 is that first term plus 60, and 60 minus 2 is 58. We got it. We got the 7th term. A sub 7 is 58. Okay, here's our next example. Go ahead and copy that into your notes. So this time I want the 30th term, and I know the 10th term and the 13th term. Here I don't know the common difference, so I'm going to have to figure that out. And actually, this one's a little tricky because I don't know the first term either. So we run into a little bit of a problem, but that's all right. We'll figure it out. Now, I'm noticing the 10th term and the 13th term are kind of close together. It sometimes helps, we talked about this last lesson, it sometimes helps to visualize here. So I'm going to draw myself some lines. This is the 10th term, right, which is 43. Then I don't know the 11th. I don't know the 12th. But I do know a sub 13 is 58. Okay, again, sometimes it just helps to see it, to visualize it. Now, you may or may not have already talked about what's called the arithmetic mean, and I know this is an arithmetic sequence, but unfortunately, the arithmetic mean, if you do know what that is, if not, you'll learn that in a later lesson, but arithmetic mean, you at least know from previous math classes what mean is. We know that's the average. If I were to try and use that here, that would get me this middle term. Well, unfortunately, there is no middle term, right? Because we have four terms here. There is not a middle. So even if I did know how to use arithmetic mean, that really wouldn't help me all that much on this particular problem. So I'm going to have to go about this a algebraic approach rather than kind of visualizing, finding the middle, and going about it that way. So we have two options for how we can do this, and I'm going to show you both here. So what I do know is I do know the 13th term, right? So if I kind of start using the arithmetic explicit, the 13th term is equal to a sub 1, which I don't know, plus d I don't know, times 13 minus 1. So that gives me the 13th term is equal to the first term plus d times 12, or 12d. Now, that's not getting me very far, right? Because I have too many variables here. I mean, I can go ahead and fill in a sub 13, that's 58. But I still don't know a sub 1 or d. So we have two variables yet, and we need to figure both of those out. Now, keep in mind, though, I can do that again with the 10th term. So I can substitute a sub 10 into the explicit. So a sub 1 plus d times 10 minus 1. And again, I know a sub 10, that's 43. So 43 equals the first term. I still don't know that, plus 10 minus 1 is 9, so 9d. Okay, so again, I still have two different variables here that I need to solve for. But we know how to solve. We basically have a system of equations here, right? We have two equations and two variables. So we know that we could solve that using substitution or elimination. I think I'm going to just solve one of these two equations for a sub 1 and substitute it in. But again, elimination would work as well. I'm going to solve this one here on the right. So if I'm solving it for a sub 1, then 43 minus 9d would be a sub 1. And I'm going to go ahead and substitute that into this other equation that I wrote a minute ago. So I have 58 is equal to a sub 1, which is 43 minus 9d, and then plus 12d. So combining like terms, 58 is equal to 43 plus 3d, I can subtract 43 from both sides, and 3d is equal to 15, and dividing both sides by 3. There we go. Now I'm getting somewhere. I have d, which is 5. Now, I still don't have a sub 1, so I'm going to have to go back here. Either the 58 equals or the 43 equals. It doesn't matter. I'm going to go to 58. So 58 is equal to the first term plus 12 times 5. This is where I'm substituting into. And so that's 58 is equal to the first term plus 60. Subtracting 60 from both sides, I know the first term is negative 2. So now that I know the first term, now I can go ahead and find the 30th term, which is what I wanted all along, using my explicit formula. So a sub 30 is equal to the first term, negative 2, plus d, which we got as 5, times n minus 1, so 30 minus 1. So the 30th term is equal to negative 2 plus 5 times 29, which means negative 2 and 5 times 29 is 145. So plus 145. 145 minus 2 is 143. That is the 30th term. Okay. Now, we had to go through several steps there to get that. Not that they were difficult steps, but it did take us a few steps to get there because we had to figure out what d was. Then we had to figure out what a sub 1 was. Then we had to figure out what the 30th term was. So I'm going to show you another approach to this problem, which is maybe just slightly easier. So we're going to take a look at that now. Okay, so remember our explicit arithmetic formula is a sub n is equal to a sub 1 plus d times the quantity of n minus 1. Now, this other approach, besides the way we just did it, what we can think of here is kind of adjusting our formula, our explicit formula a little bit. The reason that it took so many steps over here was because I didn't know both n and the first term. And so I had to figure out what, I didn't know what d and the first term was. So I had to figure both of them out. So I had to figure out what d was, then I had to figure out what a sub 1 was, then I could figure out a sub n, the term that I wanted. And it just took several steps. So to make things a little easier, if we adjust our explicit formula slightly, instead of starting it at a sub 1, we really can start it wherever we want. Here's what I mean by that. Think about any sequence that we have. Our formula simply just represents the pattern between those numbers. First of all, the pattern being what the common difference is that we're adding each time, but also where the sequence is starting and in some cases where it's ending. That's really all that equation represents. So understanding that that's what that represents is the pattern between the terms, it doesn't really matter if I call this term right here term 1 or if I call this term 10. It doesn't really matter. I'm just starting the pattern, starting my formula right there. So here's what I mean by that, and we can kind of look at the visualization that I drew here when we first started it. The very first term that we know is the 10th term, and the next term that we know is the 13th term. So what I'm suggesting here is we can just, instead of starting our formula at the first term, let's start it at the first term we know, which is the 10th term. And then let's continue on from there. So we know the 10th and the 13th. That means I'm going to put the later term here. I'm going to call n 13. So a sub 13 is equal to, and now again, I'm adjusting the formula. I don't want to start it at the first term. I'm going to start it at the 10th term. Plus d times. Now, normally it's n minus 1, but that's when we have an n here and a sub n here and an a sub 1 here. I have to adjust that a little bit because n I've replaced with 13 and 1 I've replaced with 10. So it's not going to be d times the quantity of n minus 1. It's going to be d times the quantity of 13 minus 10. Hopefully that makes sense how I adjusted that. I just started the sequence further down the line, and I didn't want to call the first term. I didn't want to start the formula with the first term. I wanted to start it with the 10th term. So adjusting the formula to make a sub 1 a sub 10 instead, and adjusting the a sub n to be a sub 13, again, that just means d times 13 minus 10. Well, 13 minus 10 is 3, and 3 times d plus the 10th term, I'm going to go ahead and fill that in, it's 43, is equal to the 13th term, I'm going to go ahead and fill that in, it's 58. Okay, and so with us adjusting that explicit formula, it actually allows us to solve this a little bit quicker. So subtracting 43, and I have 3d equals 15, and right away I have d is 5. Okay, so now I could continue from here like I did already in the doing it the other way and figure out what the first term is. But if you've understood what I did here with adjusting the formula, then hopefully you realize I don't even care about the first term. The first term doesn't matter to me. I now want the 30th term. All I need really is to know that what d is and one of the terms, wherever I want to start this sequence. So I'm going to again use my adjusted formula to get the 30th term. So I want the 30th, and what I'm going to do with that is I'm going to use the 13th term. And again, I could use the 13th or the 10th, it doesn't matter, but I'm going to put the 13th, that's where I want to start it, okay? So I'm putting the a sub 13 in the a sub 1 spot, plus d, which is 5, times, now again, it's normally n minus 1, but we have to adjust that because 30 is in the n spot, and 13 is in the 1 spot. So I'm doing 30 minus 13. And so that's going to get me the 30th term, which is the 13th term, 58, plus 5 times 30 minus 13 is 17. And that's going to get me the 30th term. So I'm going to add 58, and 5 times 17 is 85. And when I add those two together, I am getting 143. And that is the 30th term. Okay, so hopefully you can see that this way, adjusting our explicit formula just a little bit, rather than starting it at the first term, we can start it at whatever term we want. And then remember, rather than subtracting 1 in the parentheses, we're going to subtract that term number that we started at. Doing that allows me to skip that step of having to find the first term. I actually don't care about the first term. I just wanted to know what the d value was so that I could then get the 30th term. So the 30th term of this sequence is 143. All right, you're going to follow the homework assignment that is listed in Schoology, and that is what you're going to work on next.